So next concept in paging is translation look aside buffer. So it is a small improvement in your paging where it is similar to a cache memory. So we all know cache memory is the memory where we try to store the recently accessed informations. The same logic is applied in paging also using translation look aside buffer. So observe this diagram of translation look aside buffer where an extra architecture is added in this particular diagram, that is TLB, translation look aside buffer. Now what does this contains antandre, the pages which we recently accessed for execution, so those pages are present in the translation look aside buffer. Now whenever CPU wants to execute same page again, so then instead of looking for the page in page table, we try to find that page in the TLB itself. So then you can try to avoid searching the page table again and again. So for that purpose the TLB was introduced. Now the accessing page in a TLB is faster compared to accessing the page from a page table. Okay. Now there are two concepts which come across in TLB. One is called TLB hit, another one is called TLB miss anta artha. Now TLB hit means the page which we are looking for execution, if it is available in a TLB, translation look aside buffer, then it is called as TLB hit anta artha. Suppose the page which we want to access is not present in the translation look aside buffer, then it is obviously present in the page table, so you are going to access that particular page in this page table. Now that is called as TLB miss anta karitare. So accessing the page if it is not available in TLB, so access this particular page, so try to reload that particular page in the TLB for the next accessing. Now those concepts are called TLB hit and TLB miss anta karitare. So this is one important concept. So they will be asking a problem on TLB like this. Okay, consider hit ratio of memory is 80% and remaining will be how much, 20% will be the miss ratio anta artha. Hit ratio antandreno, so 80% of the time the page which you are looking for is present in the TLB memory anta artha. So remaining 20% of the time your page is not present in TLB, so you have to access the page from page table in the anta artha. So next thing they have given in your question is it takes 20 nanoseconds to search a page in TLB anta heltare, and similarly they are telling it takes 100 nanoseconds to access the page which is not there in the TLB, andre it will take 100 nanoseconds to search for the page in page table. So you can easily guess searching page from TLB is faster compared to page table. Okay, and they are asking you to calculate the effective memory access time anta helta idare. Now how to calculate memory access time is like this: hit ratio 80%, miss ratio 20%, 20 nanoseconds to search page in page table, and 100 nanoseconds to access the memory. Okay, 20 nanoseconds you take to search page and 100 nanoseconds you take to search the page from the actual memory. That's it. Okay, when page is available. When page is not available, then it will become double. Okay, you spend 20 nanoseconds to search for a page. If the page is not available, then you take 100 nanoseconds to search the page in the page table, and finally 100 nanoseconds to access the page from the physical memory. So totally 100, 120 when page is miss. When page is available, then it is 100 plus 20. So that is written in this particular problem. If page is not found, then 20 nanoseconds to search page in TLB, 100 nanoseconds to search in page table, and remaining 100 nanoseconds to access the memory anta. So that is written here. So total time taken during miss will be 20 plus 100 plus 100, so it will be 220 nanoseconds when page is not available. If page is available, then it is only 100 plus 20, so it will be 120 nanoseconds. So effective access time, how do we calculate? It is a combination of both hit ratio and miss ratio anta artha. Hit ratio means 120 nanoseconds, miss ratio means 220 nanoseconds. When we add both, we will be getting effective access time. So that is how much? 140 nanoseconds anta artha. Okay, so that's all about translation look aside buffer. So the next concept is about protection. So in protection of memory, so we are using some important additional bits in our page table. Okay, so the one bit is shown here, that is valid and invalid bit anta artha. So whenever you use that particular bit, so it means that the page what we are accessing is available in a main memory anta artha. If the page which we are going to access is not present in the main memory, then we are making that particular bit as invalid bit anta artha. So observe this example. In assume that a process is having some 6 pages, page 0 1 2 3 4 5 anta kottidare. So observe here page 0. So what does page table contains? It contains the frame number anta helide alva. So page 0 is present in which frame? Frame 2 alli ide. Okay, so it is written as valid anta kottidare. Assume here I have given here frame 6 page 3 anta kottidine, I have written it as I anta, invalid. So because page 3 is already present in frame number 1, and it is once again showing that it is available in frame 3, whereas frame 3, observe here, it is empty. There are no pages available in frame 3. So if no pages are available, it will be showing you directly it as invalid. So that's how it is trying to help the accessing of the pages from the main memory. Whether the page is present or not, you can directly find out by checking their valid and invalid bits. Okay, so the last concept which we can observe in the paging is about shared pages. So in shared pages, okay, so we try to store those data which we normally share among the users, so that we can able to avoid excess usage of the memory. So that is the main reason behind sharing of pages. So in this example they have given that suppose for example there is a text editor which is normally used by every users. So we will try to make it as the shared page. Okay, and every users are trying to store their own data or trying to create their own data. So certain amount of data will be consumed by them anta kottidare. Illi for example they have given, assume the size of the text editor is say 150 KB and 500 KB of data is used by each of the users anta kottidare. So if that is the case, how much amount of data is consumed by the users anta they have given here. Assume there are 40 users, so amount of space consumed by the 40 users will be 150 into 50, so 7500 KB of data will be used by the users. Okay, now if I use the concept of shared pages, so in shared pages all the 40 users are using the text editors, correct? So that is what it is shown in the diagram. There are two processes, okay, process P1 and process P2, and there are editors which are given here: editor 1, editor 2, editor 3, editor 1, editor 2, editor 3. So both users or processes using the editors alva. So we will make this as the shared page, so that is you can able to see it in a memory, ed1, ed2, ed3. okay, so we are just using the editor's frames in the respective page table. So this is a page table of process P1. So 3, 4 and 6 means what? These are all the editors. Similarly, page table for process P2, 3, 4, 6. So these are all the frames of the editors. Okay, only thing which is different here is page frame 1, so that is the data 1 of process P1, frame 7, that is data 2 of process P2. Only the data will be changed, but the editors will remain same. So we don't have more copies of the editors. The editors will be only one copy. Only thing is the data will be keep on varying depending on number of processes. So that's how, if we make use of shared page concept, then the amount of memory consumed will be less. So that's how it is shown here. So 150 KB of the memory is only reserved. It will not be multiplied with 40 users. So 150 plus. Only thing is we are trying to make a copy of the data space for 40 users. So that's why it is written 40 into 50. 50 KB is the data space that is for 40 users, but 150 is the editor space which is actually shared. So if that is the case, then the amount of memory consumed will be how much? Only 2150 KB, which is obviously less compared to previous that is 7500 KB of memory. So that is what the advantage of using shared pages in a paging.